Thank you all for coming. I know it's the end of the day and everybody's probably really tired from all of the knowledge that's been crammed into your brains. So I appreciate you coming by. Am I the only one today that was wearing a sport coat on stage? Yes? Okay, so here's a lesson. Just because JavaScript is classless doesn't mean you have to be. Okay. So that's the only joke. Thank you very much. A little bit about me before I get started. I'm actually working for a startup now. I'm a co-founder and chief architect at this startup called Well Furnished. And I'm not going to go too much into it. All I'm going to say is that we think there's a huge opportunity in the furniture industry because it hasn't changed in ever. And there's a lot of interesting things that we're planning on doing to help make the furniture buying experience a lot better. So go check it out. It's just wellfurnished.com. I'm very proud of it, mostly because we didn't remove any vowels from the name. Thank you. And I've written some books. So there's this one, High Performance JavaScript. This one, Professional JavaScript for Web Developers, which is really, really thick, which I think is a mark of a good book, or else a mark of me not having any life for 2 straight years. One or the other. And then the most recent one, Maintainable JavaScript. How many people got a book today? Oh, so all of you are here. Awesome. So you guys are lucky. I haven't even gotten a book yet. It just came out today. But that's where you want to go if you find this talk interesting and you want to learn a little bit more. You should go find one of those people who just had their hands up. They have a book. And you can follow me on Twitter. I am SlickNet. And if everybody goes and tweets at me right now, I can figure out how many people were in this room later. Be great. I told you that wasn't a joke. There was just one at the beginning. So talk about maintainability. Well, why do we care? Why do we care if code is maintainable or not? It's usually not the number one thing that people go in and say, well, I'm going to write code, and it's going to be the most maintainable code ever. People don't usually say that. It's not very exciting. You care because most of your time is actually spent maintaining code. So how do you know the difference? When you sit down at a computer and you open up a text editor, and that text editor is blank, that's when you are creating code. When you sit down at a text editor and you open up a file and start working, that is maintaining code. So how many people this week got to open up a new text editor and have it completely blank? This week. Oh, and then hands go down. Okay. Yeah, so it's a very small percent of everybody that was here. I'd say 10%. You don't get to do that a ton. I read something one time where somebody said, if you open up a text editor that's blank and you start typing, and then you get up and you go and get coffee, and you come back, now you're maintaining code, right? Because you're working on code that already existed. We spend most of our time maintaining code. How many people have inherited code from somebody else? Whoa, okay, lots of people. Yeah, so that's why we care about maintainability. So who exactly cares? Well, your company does, for one. So I came across this actually when I was thinking about, okay, maintainable code is good for the company, and what do you know? We just end up with Initech. But that really is the deal. If you're not coding for yourself for fun, somebody has hired you to write code to create value for that company, for that business, for that application. Right? So they actually care. Your code is supposed to keep working after you leave. That's why they hired you. If they wanted it to just work while you were there, that would be a really messed up business. Right? So your coworkers care a lot about that. I mean, especially you saw almost everybody in here inherited some code from someone else, right? So your coworkers care because the code that you're working on right now, somebody else is going to inherit. And some code that you've never seen before is all of a sudden going to end up yours sometime soon. So your coworkers care a lot. Now, it's a little bit difficult for us because as web developers, front-end engineers, UI engineers, whatever you happen to be called, we're kind of unique in our field. And that's because the sort of stuff we do is not taught in college. Right? That's huge for the number of people that we have doing this. It's not taught in college, so everybody learned on their own. How many people learned on their own what they do? Yeah, it's pretty much everybody. That's just the normal way that it is. And it's very interesting when you learn on your own, you have a tendency to develop techniques and patterns and things that you do frequently. That's your way of doing it. Right? And as part of that, it's also the best way of doing it. Right? Because it's your way. You know that it works. You've done it for years. That's the way you want it to be. I call it the rock star mentality. Right? It's all about my process, man. I've had developers tell me this. No, you don't understand. Like, in order for me to write really good code, just don't mess with what I'm doing. Like, it's a creative, beautiful thing, and you wouldn't understand. Right? The rock star mentality. But when you go to work with a team, you have to give up a little bit of that. You have to set your ego aside a little bit and really do what's good for the team. I'm a big sports fan, and I think sports teams are a great analogy for every other type of team. Because inevitably, it's the sports teams that function the best as a team that succeed versus the ones that have the best individual players. Except in tennis, where there is only individual players. So teamwork is really what we're talking about here. Whenever you're talking about maintainability, you're talking about developing as a team. How can you work on somebody else's code? How can somebody else work on your code with very little trouble? And so what is maintainable code? I like to say that maintainable code continues to work for 5 years without major changes. So why 5 years? Well, if it's 1 year, people think that you're doing a really lousy job. If every single year you have to rewrite what you have from scratch, then you're doing something wrong. You're not properly anticipating where things are going. In my experience, every 5 years, you're actually able to convince the business that it's worth the time to rewrite. Anything shorter than that, it always comes back to you as not being a good enough engineer. And so if you think about this, it's a little bit difficult because browser versions come out now several times a year. Right? We'll have like 12 editions of Chrome this year. I don't know. It'll be something insane. And so how do you make sure that your code continues to work with each of those versions without you touching it? That's the key, right? A new browser version comes out. You don't want your code to stop working because that new browser version came out. In fact, you want your code to continue working regardless of how many new browsers came out. And it can happen. I've seen it. I've done it. So how do we do this? Well, maintainable code is intuitive. What I mean by intuitive is you can look at it and you say, yeah, that kind of makes sense. I get it. I don't need to really spend a lot of time trying to figure out what this code does. I can kind of look at it and it makes sense. Understandable as well. If you actually come across something that is a little bit more complicated, being able to look at it and figure it out relatively easily is really important to this. Because it's when you don't understand code that you've inherited that you accidentally introduce bugs. And we'll talk a little bit more about that. Adaptable. So your code has to be able to change without breaking completely. That's a difficult problem. But you want whoever is going to be maintaining your code to be able to come in and make changes and know with a relative degree of certainty that things aren't going to explode. Extendable. So extendable means that the code can be built upon to do more things. So you don't have to completely rewrite that particular part because you need to add some additional features. You can continue to build on top of it. Debuggable, which is not a real word, by the way, if you look it up, according to Microsoft Word anyways. Being debuggable is so important. Setting up your code so that somebody can easily step through it and figure out what's going on is huge to the maintenance process. And lastly, testable. So if you write your code in such a way that you can write unit tests, you can write functional tests, things like that, it's going to save you a lot of time down the road. In fact, there is a new O'Reilly book I saw out there called Writing Testable Code. which seems like it would be a good thing to pick up. So Chris Epstein, creator of Compass, had a great phrase, which is be kind to your future self. Right? As you're writing code, the person that has to maintain it might actually be you. So what would you want to do for yourself? Like leave a maze, Indiana Jones style, where there's just like little tips here and little tips there that you have to follow to figure out what the hell you were thinking about 5 years ago? No. You want to leave little breadcrumbs along the way so you can help yourself, your future self, and other people to figure out what's going on. And that's when we talk about code conventions. So code conventions now are starting to be discussed a lot more, which is very exciting. There are actually two types. And so there's code style, styling guidelines, which has to do with syntax and spacing. And there's also programming practices, which are like baby design patterns, like common ways of doing certain things. I'm going to start with the style guide. So I'd like to say that code style is the way that developers communicate with each other through the code. It's a common vocabulary that everybody understands and everybody speaks. And that lets you move seamlessly from file to file to file when you're working in a large project. So Donald Knuth, how many people know Knuth? Excellent, he is my homeboy. He said, programs are meant to be read by humans and only incidentally for computers to execute. Right? Because the code, again, it's a communication medium between developers. And then it gets interpreted by the computer to do something interesting. Right? But first and foremost, it has to be understandable to developers. If that wasn't true, we'd all still be writing assembly right now. And in fact, most of us probably wouldn't be here because we'd be doing something else. Good code is appreciated by people. So my buddy Tom gave a talk earlier. We were having a little Twitter conversation back and forth about how beautiful my code was, and that's what it was. I wouldn't recommend doing that on a first or second date, but a little bit down the line might be okay. There's a bunch of guides out there that you can take a look at. Doug Crockford, of course, has an opinion about everything in JavaScript, and he also has an opinion about code conventions, which covers both style and programming practices. There's a Google JavaScript style guide that is maintained by the folks at Google and written by a lot of smart folks at Google that a lot of people sort of use this as their starting point when they want to do a style guide. jQuery, the jQuery core has a style guide as well. And I'm sharing all of these with you, by the way, knowing that they all have slightly different stylistic tendencies, but you should look at them and figure out what makes sense for you. Dojo also has one, as a style guide. And most recently, Rick Waldron from Boku has started putting together this project called Idiomatic.js, which is also a collection of recommendations around coding style and conventions. These are all excellent to go and start looking through in order to figure out what sort of style you like. I also go through that in the book, kind of comparing and contrasting all of the different styles in these different guides. So you should be prepared, because when you talk about coding style, you will fight. You will fight viciously. You will hate the other people on your team, because some people want spaces for indentation, and some people want tabs for indentation. So I'm not kidding about this, I have had in my career a 45-minute conversation about indentation. We set up an hour meeting to discuss style guide, and 45 minutes were spent on indentation. That was not a good use of our time. I have since learned that we shouldn't be spending so much time on such things. However, it's not uncommon to have people on the same team disagree. So when that happens, you just need to come to an agreement. Again, one thing isn't good and the other isn't bad. What's important is that there's one way to do it and that everybody does it that way, So, if your process is your rock star is tabs for indentation and your team has decided that they're going to do spaces, do the spaces. Like, be a team player, because otherwise you open up code and it ends up looking like this. And this is why I always start with indentation for something to figure out is how many people have ever opened up a file and before doing anything re-indented the entire file, yeah? Right. Because unless it's indented your way, you have no idea what the hell that code is doing. Yeah, so pick one, stick with it, don't mix, because you end up with crap like this. It should look like this. It's a lot more readable. It's pretty. It makes my heart sing. And we move on. So another thing, the less code on one line, the less likely you'll encounter a merge conflict. So I know that there are some people out there that love to write a single line of code that just goes on forever. Right, I've seen it in JavaScript. I've seen it in CSS, stuff like that. Again, okay if you're the only person working on the code. Not okay if you're working in a code base with other people because source control does merges by line. And so if your entire program is on one line, that's going to be a big problem if two people are working on it at the same time. So I prefer to space things out a little bit. Make your lines as short as makes sense, right, to avoid the merge conflicts. Comments, one of my favorite topics. So self-documenting code is a myth perpetuated by those who hate to write documentation. I firmly believe this. I don't care if you write the best code in the world. There is nothing that will make it more understandable than a few well-placed comments in that code. The point is, I shouldn't have to actually read the entire file before I understand what the code is doing. If I actually have to fall through, okay, if, okay, yeah, do, yeah, that takes a while before you can actually grok what the file is doing. Throwing in some comments here and there, not too much. Right? Don't want to repeat what the code is doing. That's a little bit silly. But like seasoning, you just want to put just enough because that really helps the understanding of other people. So I love documentation comments for documentation generators. They usually kind of look like this, the sort of Java doc style. At the very least, please do this for your methods. Anything more than that is a bonus, but at least doing this goes a really long way towards developer understanding. Also, difficult to understand code. So this is something that I think a lot of developers miss, is that if you're writing code that when you look at it, you're like, oh, yeah, well, I know what this does because I know that I did this, and I did that, and I did that. That's where you need some comments, because nobody else has that insider knowledge that you had when you first wrote that code. So this is an example that comes from YUI. There's a very long function, and I got to this part, and I was like, wow, if there weren't comments there, I would have no clue what this is doing. So this really helps out. Any of those little places, again, like leaving Post-it notes for your future self and for other people who are looking at the code is very useful. Very important one, code that might seem wrong when you first look at it. I have seen so many bugs by well-meaning developers because somebody did something a little funky so that it looked wrong, and a helpful colleague came along and was like, oh, that dude totally messed up. Like, I'm just going to fix this, and he's going to be so happy, right? And then what happens? Regression, right? An old bug all of a sudden pops up again. That's not cool. So here, I don't know if this laser thing is going to work. Let's try it. Bam. Have a little equals sign, right? Where initially you would look at it and be like, well, that's a little weird, because you expect a Boolean value as the control condition, but yet there's an assignment in there. Clearly that must be a mistake. I'm just going to add the double equals in there, and I'm going to fix that problem. Right? Except in this case, it was actually intentional. And the only way that you know that is because there's a comment there saying, note, assignment. I meant to do that. Please don't fix this. Please don't fix this. Right? Another common place where this happens is when you have browser-specific code due to an error that exists in just one browser. A lot of times, like you'll do like the standard thing, and then you'll test in another browser, and you'll find that the standard thing doesn't work, and so you have to hack something together just to make sure that it works. And if you were to look at that, you would say like, well, this guy obviously didn't know what was going on, because if he did, he would just use the standard thing, because clearly we all know that that works everywhere, and then removing the other part, and then all of a sudden you have a regression again. Right? So anytime there's something that might seem like a mistake, that's a good place to throw in a little comment. Okay, so naming, one of the hard parts of coding. So use logical names, please. I don't know, anybody in Kent Brewster's talk prior to this? Yeah, so I love Kent. I used to work with Kent at Yahoo, but oh my God, looking at his code makes my brain explode. And part of that is because he uses all single character variables in his JavaScript. And that's great for him to understand. But if I had to work on his code, I would probably start by replacing all of those with more logical names. So use logical names for both your functions and your variables. And don't worry about the length. Name it the way that it should be named. You can always run your code through something afterwards to shrink those names if you want to. But remember, you're trying to communicate both with yourself and other developers through code. So use logical names. Some little things, variable names should be nouns, book, person, name, blah, blah, blah. Function names generally begin with a verb. It helps because functions do stuff, verbs do stuff. I think my English teacher parents would be very proud of me for that definition. Verbs do stuff. Functions that return Booleans usually begin with is and has. I'm just going to blast through this stuff. Avoid useless names like foo and temp. So they are moderately better than single character variables, but by only the teeniest, tiniest bit. Doesn't help me at all. Right, so that same code that I showed you earlier, it's like, oh my God, what the hell is all of this crap? It is just a complete and utter nightmare. I have no idea, and I know for a fact, by the way, that this was handwritten by somebody whose name I won't mention. So camel casing is the way that we usually name things in JavaScript, and that's because that's how the native APIs are done. Right, so camel casing is each word is separated by a capital letter of the next word. And in cases of variables, functions, stuff like that, you start with lowercase. So you have my name, say name, all of this stuff. Right? So what about acronyms? Love this question. It's one of my favorite ones to deal with camel case. It's because it's like, okay, you can either treat an acronym like it's a word. And so everything is lowercase, and then if it's a new word, then you have an initial uppercase letter. Or you can just treat it like an acronym, so it's all uppercase. So when you start to look at like native APIs for this stuff, we have like get element by ID, right? So ID is treated like a word here. So it's get element by id for a slightly Freudian twist. And then we have inner HTML, which is treated like an acronym. Really? It's like JavaScript itself is insanely inconsistent in this. Please pick one, stick with it. Oh, this is my favorite one, right? Like, no, wait, like, so you have XML, which is an acronym, yeah? And then you have HTTP, which is an acronym. Like, what is going on? Oh my God, I just can't deal with it. So some exceptions, if you're using constant-like variables, because JavaScript doesn't have constants yet, a lot of times you see this pattern. This is recommended in a lot of the style guides, to use all uppercase and underscore to separate words, and that's kind of a holdover from like C and C++, where that's pretty common. But it's actually very useful to make sure that you don't accidentally assign to something that you intend to be a constant. Right? And then constructors usually have the first letter be uppercase. Okay, so now I'm going to talk a little bit about programming practices. The style stuff, there's a lot more to that. Go look at the style guides, read the book, because you could literally talk like 3 hours on just style stuff. And I want to move along because I know we're at the end of the day. So programming practices. This is one of my favorite quotes. There are two ways of constructing a software design. One way is to make it so simple that there are obviously no deficiencies, and the other is to make it so complicated that there are no obvious deficiencies. And this dude is one of the guys who came up with quicksort, which if you were in a computer science program, you probably learned about it. So programming practices help to make your code simple so that other people can understand it, you can understand it, and things don't break. So one of my favorite practices is making sure to keep the front-end layers separate. And so you have your CSS, which is for presentation, you have your JavaScript, which is for behavior, and you have your HTML, which is for your data and your structure. And I like to keep those as separate as possible. So basically, don't cross the streams. Right? Who thought they would see a Ghostbusters reference today? Ralph, really? You did? That's incredible. You saw the slides online earlier. I know, right? So this is bad. I'm guessing all of you know that this is bad. If you don't, this is bad. Putting JavaScript inline in your HTML is something that you should avoid at all costs. Why? So I'm going to go back to my made-up word debuggable. Right? If you come across a JavaScript error, where do you want to go to find that error? In your JavaScript files. If there's a JavaScript error, you don't want to have to go into your HTML. Right? That doesn't make any sense. You lose a lot of time that way. Also, keep your HTML out of JavaScript. I absolutely cannot stand when I see long strings of HTML embedded inside of JavaScript. Why? Same thing. If there's something wrong with your layout, where do you want to go to find the problem? Your HTML and your templates. Right? You don't want to have to dig through your JavaScript because that particular thing happened to be generated in the JavaScript while everything else was generated someplace else. Just as an asterisk to this, I'm not saying don't use things like mustache and handlebars and stuff like that. I'm actually saying use those because that allows you to keep your templates all in one place, and then you can compile it into JavaScript that you don't have to edit by hand. And that means if there's a problem in your layout, you can go to the templates and fix it in the templates, and then pull that back into your JavaScript. It's a great solution to avoid this problem. Another one is to actually pull back markup from the server and inject it into the page. But do not have HTML strings inside of your JavaScript. Big pain. Keep JavaScript out of CSS. So thankfully, IE has finally removed this capability. Thank God. I'm going to tell you a little story. It's very little, I promise. I know, we're at the end of the day. So I was working at a company several years ago before I moved to California. And there was a JavaScript error. And I spent a day trying to figure out where that JavaScript error was coming from. I couldn't do it. It's like the debugger wasn't picking it up. And of course, at that time, it was like, IE6 and Visual Studio I was using. And I was pulling out hair. At that time, I had hair. I was pulling it out. And finally, I was like, okay, you know what? I'm just going to do this as brute force as I can. And I'm going to start removing JavaScript from the page. And I removed it function by function and then file by file until I had no JavaScript on the page and hit F5 and a JavaScript error popped up. And at that point, I was about to go crazy. So like, this should not technically be possible if there's no JavaScript on the page and there's a JavaScript error. And before, it was a good thing that the alcohol was on the other side of the building. And I don't know why. To this day, I still have no idea what divine inspiration caused me to go and look in the CSS and find one of these expressions. But that's what it was. And that was actually when I first came up with this rule. It's like, yeah, because when I see a JavaScript error, the first place I think to go and look for it is in CSS. All right? Don't do it. And keep CSS out of JavaScript. So modifying that style property on elements is not an awesome idea. Why? Same thing. If there's something wrong with your styling, you want to be able to go to your CSS and address it there. You don't want to look there, spend days trying to figure out where it's coming from, only to have it in your JavaScript. It's a big pain. So event handlers. A lot of people do event handlers the wrong way. And that is the way that you see here. There's too much going on in this event handler. It's getting a bunch of data off of the event, and it's creating a pop-up, and it's showing it, or something like that. Your event handlers should be very small and only handle events themselves. So this is a good first step. Right? This event handler is just handling the event, and then it's calling something else to actually perform an action. So that's useful in terms of testability. Is now I can call that show pop-up from wherever I want. It doesn't have to be from within that event handler. So I could call it from handle click. I could also call it from something on mouse down, on hover if you want to really piss people off. Any place like that. That's what makes your code more testable, is being able to get at different pieces of the code without actually having to go through and interact with it like a normal user. So this is still not the best because you're passing the event object around. I hate passing the event object around. Why? Because then if you want to call that method someplace else, you have to have an event object to pass in. It's also not very transparent as to what you care about on that event object. So in this case, I only care about two pieces of data, client X and client Y. Well, how do I know that from the outside? I don't. So I actually have to stub out the entire event object. Well, that's not cool. It'd be much better to do it this way. Right, so your handle click, all it does is take the data that is needed for the next step and hand that off. So now show pop-up is actually a completely standalone function at this point. You can pass in an X and a Y, however you want for testing, or if you just decided a different part of your application, you want to use different values in there, you can do that. And then handle click just becomes something that's part of your interface rather than something that is part of like your core functionality. Right? And then you can change event handlers later really easily. It is full of win all around. Don't modify objects you don't own. Please, for heaven's sake. This is something I actually started talking about 5 years ago, and people started biting my head off very quickly about it because JavaScript is dynamic, right? Like I can just add whatever crap I want in there, and it's totally okay. Right? Because I'm a rock star, we do that. Again, it's okay if you're the only one working on this project. It's okay to mess around however you want. As soon as you're working on a team, modifying objects that you don't own is terrible. Why? Because the objects that you don't own, they're either part of the browser API themselves, or they're part of a library. And the other people on the team who are using those have an expectation about how they're going to work. If you change that, you've broken that expectation, and now it's basically a minefield. Nobody knows what to expect in that development environment anymore. So I actually had this happen to me, one of my jobs. We were using YUI2, and there was a method on event called stop event. And we had an error that literally 3 developers, including myself, were trying to figure out where this error was coming from. And we finally were able to track it down after several days to somebody who had overridden stop event with something else. Because they had a specific use case, and they thought that stop event would be much more useful if it did something else. Didn't tell any of us. And so we were all using it the way that it was documented, and stuff broke. All right, so overriding methods is bad. Adding new methods is bad as well, because you don't know what browsers are going to add in the future. And you may add something that has the same name as something that a browser adds in the future, and that is a problem because chances are they won't work exactly the same. Case in point, the prototype JavaScript library invented document.getElements by class name. That was part of that library before it was part of HTML5. HTML5 copied it from prototype. Right? And it is a very cool function. The problem is that because Prototype implemented it their way, and the HTML5 way was slightly different, there was an incompatibility there that caused people who were using Prototype to have their code break when these HTML5 browsers started coming out. And Prototype was trying to do the right thing, because they basically said, if this function already exists, don't overwrite it. But if it doesn't exist, then add it. But because those two work slightly differently, and people were coding against their original version, when the HTML5 version came out, the world broke. It's unfortunate, but a good lesson in why you shouldn't be adding methods to objects that you don't know. And I wrote a very lengthy blog post about that. If you want to learn more about it, it's also in the book. We'll move on. Avoid global functions and variables. This one you've probably heard multiple times. So my previous example was kind of lousy about that. I would just fix it by throwing it onto a top-level global. Throw your own errors. This is something that not enough developers do. So when I was a young developer, sounds like the beginning of a song or something. When I was a young developer working in Java, it does sound like the beginning of a song. When I was a young, okay. I remember seeing this throw, right? So throw new exception. I was like, why the hell would you do that? You're causing an error? Isn't our whole job as developers to avoid errors? That didn't make any sense to me whatsoever. Now, I'm being older and wiser, well, arguably wiser. I realized that throwing errors is actually a really, really helpful thing. This is another post-it note that you can leave yourself in your code. And it really helps when you know that there's an area where an error might occur, and you might have a hard time tracking it down. Right, so in this case, this function could fail if element was null. Right? And you'd get some really stupid browser error message like, class name cannot be read from null, or some such thing like that, which tells you nothing at all. And then you start digging through the code to figure out where that was, and you set breakpoints, and you eventually figure it out. I don't like when errors happen, and I have no idea where they're coming from. That's not good. So if you throw your own error, you can basically leave yourself a note to say, if this condition happened, here's what the problem is. So if I didn't get an element being passed in, I'm just going to throw an error. I always like putting the method name in there, because that helps me very quickly to get to the point of knowing where that's coming from, and then what the actual error is. Now, don't go crazy. Don't try to mimic statically typed languages. Don't do this for every single argument of every single function. Then you're doing it too much. Just the places where either you end up seeing an error or you're exposing an API where it's usually one of the arguments is most important to that function, or two arguments, just to help people out. It's especially important, libraries like YUI and jQuery usually do a pretty good job of this, where if you call something and you're passing in a null value, they tend to give you an error message that kind of makes sense, so it can help you track down a little bit easier. Avoid null comparisons. So I see way too many pieces of code that just say, well, if this thing isn't equal to null, then do something. But that's usually not specific enough. Unless you had a variable that you specifically set to null, and then it had a chance of having its value change later. And so you're basically just checking to see if the value changed from the first one that you set. It's usually not enough to test against null. So in this example, if items is not equal to null, you're going to do a bunch of stuff. All right, but that means you could pass in true, 1, a string, any of that, and it would go through, and then it would fail on sort. So doing something like this, items instance of array, is really helpful. One, because it states your intent a little bit better, and it also protects you from some of those fall-throughs from bad checking. So if you're checking against specific object types, you can use instance of. Object instance of the constructor returns true if it's an instance of that. And then type of is for primitive values. So strings, booleans, numbers, even functions work very well. But in case you weren't aware, type of null is equal to object. So just be careful of that. Separate config data. So I don't like to see strings inside, well, strings are other values inside of JavaScript that are application configuration or things that will change. Right, so in this example, you have a UI string, so something that's going to be presented to the user, and you also have a URL. These are both things that I guarantee you will change, and will probably change frequently before you ship. And for that reason, you want to separate them out. Right? You want to keep that data away from your application logic. Right? Because when you want to change that data, you don't want to risk messing up your application logic. Right? When you change data, you shouldn't have to rerun unit tests to make sure that the logic still remains the same. So separating it out like this is a good first step. So all URLs, absolutely all URLs should be pulled out of the body of your JavaScript. They change way too frequently. Strings that are displayed to the user, any HTML like I talked about earlier, use some templating like mustache, dust, associated things. Any settings, such as how many things are on the page. Any repeated unique values. So if you are using the same class name multiple times, if you are using the same maximum number of whatever multiple times, that should be pulled out because you want to have one spot to change that value rather than multiple ones. And of course, any value that can change in the future. So I wrote this little tool to help with this. It's called props to JS, and I do give props to JS, but that's not the point. This will take Java properties files and convert it into JavaScript for you. So you can even have an easier way of managing your configuration data as just simple key value pairs, simpler syntax, and then be able to convert that into JavaScript for your project. Okay, last section is on automation. When I first started talking about this several years ago, automation for JavaScript and front-end stuff was almost non-existent. Now it's around, and there's a bunch of tools. And I'm just going to breeze through this kind of quickly to give you an idea. There's a lot more in the book. There's a ton of resources online I'll talk about. I think that build processes are magic. And I was sad that it took so long before JavaScript developers really took to this. But the idea that you can take a whole bunch of files and then process them in some way and come out with a concatenated file or a couple of files at the other end is awesome. It makes your life so much easier, and it makes your code more maintainable because you can automatically run all kinds of checks on your code to make sure that things are still working the way that they should be. So when you're talking about a build, I'm talking about a bunch of steps. So you could be adding and removing debugging code. You could be concatenating files, generating documentation, validating code, testing your code, minifying files, deploying files. All of these are great parts of automation. And there's a bunch of tools to help with all of this stuff. JS Build Tools has a preprocessor. It's the only one that I've found thus far that's pretty easy to use, where you can very easily tag code as being just for like debug mode or another mode using C-style, if-def, stuff like that. And we have, for documentation, JSDoc is one of the more popular ones. By the way, all these slides will be online, so don't worry about jotting down all of these URLs. YUIDoc is another one that works similar to JSDoc. One that's a little bit different is Doco. Creates side-by-side documentation with source code. To validate code, there's JSLint. Crockford has since updated the design of that site. I was way too lazy to fix my slides, but wow. There's also JSHint, which is, has a bunch more configuration options. For minifying files, YUI compressor, which was the gold standard for a long time because it does that variable name replacement, so replacing a lot of the short function names and variable names with shorter versions of them automatically for you. And then there's Uglify.js, which got more popular recently. It does that and a bunch of other weird stuff to your code to make it even smaller. A lot of projects are moving to this now. There's the Clojure compiler from Google. which does a lot of similar things as Uglify and YUI compressor, and is also built to work with a lot of their other tools as well. For the overall build, I really love Apache Ant, which is a Java build tool. And it works really great for JavaScript because it has a lot of built-in tasks that are really useful, such as for concatenating files, things like that. Julien Lecomte, who wrote the YUI compressor, wrote a really good article about using Ant for building JavaScript and CSS and stuff like that. More recently, there is Grunt, which is a JavaScript-based. Okay. That is my you better hurry the hell up. Grunt is a JavaScript-based build tool, and there's a little article about that too that you can grab off of the slides. So for your build, you actually want to have a bunch of different types of builds, right? So you have your deployment, your testing, your development, and all of those can do like different sets of each of these. Right? And that's a really great way to both work locally as a developer and also to continue on through your deployment process. So at the end, code style guidelines, really important to make sure everybody on your team is speaking the same language. Loose coupling of layers really helps with debuggability. Good programming practices also for debugging. Code organization and automation will help you bring some sanity into your process. And if I can leave you with one last thought, is that always code as if the guy who ends up maintaining your code will be a violent psychopath who knows where you live. So that is it. There's the various places to reach me.